best of modern physics. Salvation came in the unlikely form of this man. Meet Peter Higgs, an unassuming professor who set off one of the largest and most expensive investigations in the history of science. There was a gaping hole in the standard model of the universe. Peter Higgs put a plug in it. Higgs theorized that a vast field stretching to infinity runs through everything. When certain kinds of particles interact with the field, that interaction is what gives those particles mass. If Higgs' theory becomes fact, we may finally understand why things are solid. But at first, Higgs had trouble getting his theory accepted. A paper outlining the idea was rejected by CERN.
I was indignant because I thought what I'd done had possibly important consequences. So I rewrote the paper by adding on some extra paragraphs. And instead of sending it back to Geneva, where I thought the people at CERN didn't understand what I was talking about, I sent it across the Atlantic to Physical Review Letters, the corresponding American journal, and it was accepted.
The paragraphs Higgs added predicted that the mass-giving field would have a matching particle, a force carrier called the Higgs boson. And this matching particle could theoretically be created in a particle accelerator. Gradually, experimental physicists became excited by Higgs' idea.
What happens with the theory is, of course, a small number of theorists push this idea. They love it. And little by little, more and more theorists climb on board. You know, it's like the train. Woo, woo, we're taking off from the station.
In one of the great ironies of modern science, CERN, the organization that rejected Higgs' paper, has just spent $10 billion building a machine to find the Higgs particle. But what exactly is the Higgs? Ask a half dozen physicists and you'll get a half dozen different answers.
The Higgs.
It's a tricky thing to come up with an analogy for the Higgs boson.
There's the analogy with something being dragged through treacle, but for me that's misleading because this is a dissipation of energy, and it isn't like that.
That's a pretty bad analogy for the Higgs.
What I've read on the Higgs is, in my mind, very confusing. Here's the way I understand it. A bunch of reporters standing in a room, crowded room. And so me and President Obama want to make it from the entrance of this room to the exit of this room. So we go in, and what happens? Of course, all the reporters glom on Mr. Obama. And Obama over here, he just makes a beeline right to the exit door. So basically, with no inertia, I can make it to that door. Whereas Mr. Obama has a lot of inertia, a lot of mass. So this Higgs field affects one particle more so than another particle.
We must be able to come up with a more...
Well, when we see what they look like, we'll come up with a better analogy, right?
Another analogy, yeah. Something involving cars or something. No, I don't know.